Chapter 23, Section 1, we're talking about amines here. Amines are a very rich functional group that enter into alkaloids. Alkaloid means basic, and basically these different alkaloids might taste a little bit basic if you were to taste them. Not recommended for some of these, other ones, I don't know. So, of course, we're looking at a nitrogen surrounded by different alkyl groups. So here's a nitrogen highlighted here, and it's surrounded by 1, 2, 3 ordinary carbons. And this is morphine. We know where that comes from, the opium, the poppy seeds. And then this second molecule here is cocaine. That comes from the cocoa plant, and it's a strong anesthetic, for example, that's used in nasal surgery, among other things. On the right is nicotine. Nicotine is, of course, found in the tobacco plant, and it's a poison. It deters insects from feeding on it. Now, this nitrogen is surrounded by 3 carbons, and this nitrogen here, if I might draw the lone pairs, is part of a heterocyclic aromatic ring, okay? So it's an aromatic ring, and we call this a nitrogen heterocycle, okay, or nitrogen aromatic ring. On the top left is atropine. This is found in belladonna plants. Belladonna in Italian means pretty lady, and it's used to dilate the pupils. And people thought back then, and maybe still now, that if you have a very large pupil, you look more pretty. They use this in the eye doctor's office when they need to dilate your pupils to get a better look inside of your eye. Okay, so here we have a nitrogen that's surrounded by 3 carbons, so that's an ordinary amine. I find it interesting how it's very similar to cocaine. Cocaine, of course, has effects on the heart, and atropine as well is injected for different reasons to stimulate somebody's heart. Okay, on the bottom left we have what is this? Adrenaline. Okay, adrenaline, is responsible for the fight or flight response, and it can get your heartbeat up really fast. It can dilate blood vessels, things like this. So here's the nitrogen atom, and this is surrounded by 2 carbon atoms. This guy here in the bottom middle is histrioconatoxin, and it's it's used for the poisonous dart arrows, okay? So poisonous darts and to make poisonous arrows, and this is used by the native Indians in Colombia. They basically torture a frog, and the glands in the frog produce a liquid that they can then coat on up to about 50 arrows. And when they shoot this into a monkey or other animals in the forest, they can basically, it paralyzes them, okay? Here is the nitrogen atom here, and it's surrounded by 2 carbon atoms, okay? So these are your basic structures. They're very interesting natural products. There are many synthetic drugs that are alkaloids. Things like methamphetamine and other kinds of molecules, for example, that's used right now in allergy season, okay? Claritin, for example. Benadryl, for example, is an amine. So let's just move on and talk about the classification that we have for amines, okay? Amines can be classified as primary, secondary, or tertiary. We, of course, have this inorganic molecule called ammonia, and we are going to be using this in synthesis, so memorize ammonia is NH3. Now, if one of these hydrogens is bonded to an alkyl group, it doesn't matter if it's a methyl or an ethyl or whatever, we can call this a primary amine, okay? Because the nitrogen is bonded to 1 carbon atom. If we have a amine that's bonded to 2 carbon atoms, we would call this a secondary amine. So this might be cyclic, for example, okay? So here are examples of secondary amines. All right, and all you need to do is count the number of carbons bonded to the nitrogen. So this has 2, and this has 2. A tertiary amine is one in which you have 3 carbons surrounding the nitrogen, okay? So this would be called a tertiary amine. Now I should mention, I guess I faultily in error made an assumption that we all know that nitrogen has an octet, and so there's a lone pair on all of these guys here, okay? There's a lone pair on the nitrogen to give it a total of 8 electrons, okay? So it has 3 bonds, and it has a lone pair, and it has a formal charge of 0 in all of these structures. Now a quaternary amine is a nitrogen atom that's bonded to 4 groups, okay? So that might be a CH3, a CH3, a CH3, and maybe a benzyl group, okay? So this guy here, benzyl trimethylammonium chloride, for example, is a disinfectant, and this is found in those bleach-free disinfection wipes that you find all over the place now due to the COVID epidemic, okay, pandemic. So you have these, these wipes that you can wipe down a surface, and they don't smell like bleach. They're just, you don't smell anything. And so this is a disinfectant, okay? But here, nitrogen is bonded to 4 things, so it has a +1 formal charge, and so there's an accompanying counter ion to balance that. So you've got to include the chloride with the structure, okay? So we will see reactions where we alkylate amines and we form this quaternary structure, and be sure to include the counter ion, okay? Now there are heterocyclic compounds as well, but I'll save that for later on when we talk about those, okay? So for now you have primary, secondary, tertiary, and then quaternary amines, okay? Now we're going to see amines participate in 2 main types of reactions, okay? Amines, since they have a lone pair, can act as a nucleophile, okay? So remember that whenever you have a base, you have a lone pair, and this can protonate, okay, when it reacts with an acid, okay? I'll just leave the charges off there. We're not really worried about this at this moment. Now if you have, so as an example of this, so this is an acid-base reaction. Amines are basic. As I mentioned, natural products that have amines in them are called alkaloids because they're basic. One of the first ways to characterize them was to taste them on the tongue, and they tasted bitter. Okay? So if we have trimethylamine, okay, and we treat this with hydrogen chloride, what will we get? Well, there's a lone pair here on this nitrogen atom that acts as a base, so we're going to protonate the nitrogen and give us a protonated amine, okay? So now nitrogen has 4 bonds, and it's going to have a positive charge, and you have a chloride floating around there, okay? So we oftentimes call the molecule on the left the free base, okay? And this is a pharmaceutical term. It's an organic chemistry term. It's not a holiday, sorry, I meant to say a Hollywood term like, oh, that's the free base of cocaine or something like that, okay? We're not talking about crystal meth here. We're just talking about, in general, in very general terms, this amine has no hydrogen. It's not protonated, so we call it the free base, okay? And over here, this is the protonated form, okay? So that's reaction number 1. Reaction number 2 is going to be a nucleophilic reaction, okay? Remember that nucleophiles have lone pairs, and so they can participate in reactions. So for example, if I want to attack methyl iodide, right, the nucleophile can attack the methyl group, kick off iodide, and you make a new bond, okay, and you kick off your leaving group. So amines are very nucleophilic, and this is because if you look in the periodic table, okay, compared to your halogens and so on and so forth, it's the element furthest to the left with lone pairs that we talk about. It's there on the left, and so we say nitrogen is electropositive, okay. This is the opposite of electronegativity, right? It's electropositive. You can correct my spelling there on your own if you're taking notes. And that means that it's going to more likely donate its electrons as a base. It's more likely to donate its electrons as a nucleophile. So we can take, for example, trimethylamine once again. All right, with lone pairs there. And we can attack, let's attack benzyl bromide here. Okay, so remember again, in the SN2 reaction, primary and secondary alkyl halides are best for this reaction, and methyl halides. So here we have the lone pair attacking this carbon, and this doesn't have very much sterics. It kicks off the bromide, and what we get from this chemical reaction is benzyl trimethyl ammonium bromide. And since there's a positive charge on the nitrogen, you know, it's not showing what counterion is there. The bromide is actually part of this product, okay? So we're actually making an organic salt. So that is the product there, and this is an SN2 reaction. So those are the two main types of reactions we're going to see in this whole chapter. Let's get started with section 2 now. All right, thanks for watching.